Good day, I am Yvonne Villanueva and I will discuss the response spectrum analysis or RSA of a 10-story building based on NSCP 2015 Dynamic Analysis Section 208.5. An example is a 10-story building with the floor-to-floor height of 3 meters. Perform RSA dynamic procedure based on NSCP 2015. So let R equals 8.5, CA equals 0.44, CV is equals to 0.64. So we have 15 steps in doing response spectrum analysis or RSA. The stiffness and mass are given, and the frequency, period, and eigenvalue are also given. So later on, we will know how to come up with that result. Step 1. Compute the mass and stiffness in each story. So the stiffness and mass are given. So here are the formulas. Since given naman siya, di na siya kailangan i-solve. So, step 2, set up the characteristic equation and calculate eigenvalue. To calculate the eigenvalue, we have characteristic equation k minus lambda m. By that, we can determine the eigenvalue of each mode. Step 3, calculate the modal frequency and modal period. So, to find the modal frequency, we need to square root the lambda or the eigenvalue. Modal period is equals to 2 pi over modal frequency. Since the lambda or the eigenvalue is already determined, so we can easily find the modal frequency and modal period. Step 4. Calculate the eigenvectors for each eigenvalue. Para makalculate, gamitin natin yung characteristic equation na k minus lambda m. So, dito na matrix, makikita natin na merong lambda. So, isubstitute natin yung lambda every mode. For example, in mode 1, we have lambda equals 32. So, lahat ng lambda na makikita natin, isubstitute natin ng 32 para makuha natin itong result na ito using Excel. So, same process lang siya sa pagkuha din para sa mode 2 hanggang mode 10. Tapos, itong equation or itong result na ito, i-multiply natin sa eigenvectors. Pero, no solution kahit merong 10 equation and 10 unknowns. Ang gawin is, i-equate natin ang last mode to 1 at eliminate ang last row and then transpose the last column to the right portion. Ang negative values ay magiging positive. So, meron na tayong 9 by 9 matrix, 9 equation, and 9 unknowns with equation. So, ito na yung result ng every mode. Same process lang every mode. Ang eigenvector is yung mag-determine ng mode shape. So, ito yung mga mode shape ng every mode. So, ito naman kung kung isama mo yung lahat na mode shape. Ito yung itsura niya. Step 5. Compute the modal participation factor. So, ito yung result natin kanina sa eigenvector of every mode. To compute the modal participation factors are, ito yung formula. R is equals to generalized mass matrix over coefficient vector. To determine the generalized mass matrix, it is the formula. Generalized mass matrix equals to transpose eigenvector multiply to mass matrix, then multiply to eigenvector. Sa pag-transpose, yung row is magiging column. Yung column is magiging row. Using Excel, ito na yung magiging result niya. For coefficient vector L, here is the formula. The D is the directional displacement unit vector. Si D is yung mag-determine kung i-consider natin yung mode in direction. Dito is i-consider natin lahat ng modes at floor. Using the Excel, makukuha na natin ang value ni L. Since nakuha na natin sa generalized mass matrix at coefficient vector, pwede na natin makuha ang modal participation factor R. So, ito na yung result niya. Ito is using Excel. If i-add natin ito lahat, magiging equals to 1 ito siya. Step 6. Compute the modal mass participation percentage. So, we will know kung anong mode yung grabe mag-participate. First, determine muna natin si effective modal mass with a formula of L multiplied by modal participation factors na na-compute na natin kanina. Then, it is the result. Ito na yung ating effective modal mass. Yung makikita natin sa baba na total mass na 13.950, ito yung summation of mass matrix na given. So, makukuha na natin si modal mass participation percentage since meron na tayong value ni effective modal mass at total mass. With this formula, using Excel, ito na yung result na ang modal ng result ng modal mass participation percentage of every mode. So, according to NSCP 2015, at least 90% will participate. So, in this result, pwede na si mode 1 and mode 2 kasi nakaabot na sila ng 90%, pero need pa rin natin i-consider yung ibang mode. Step 7. Determine the corresponding spectral acceleration based on the different modal periods using figure 208 to 3 of NSCP 2015. So, the period is given. The CA is equals to 0.44 and CV is equal to 0.64 is also given. So, in SCP 2015 figure 208 to 3, formula for TS is equals to CV over 2.5 CA. So, we have 0.582. So, 0.2 TS is equals to 0.2 times the TS. So, yes, the 0.582 is equals to 0.1164. So, itong value na ito is magagamit natin mamaya. For TN is less than 0.2 TS, ito yung magiging formula niya. For 0.2 TS is less than or equal to TN, less than or equal to TS. So, ito naman yung magiging formula niya. For TN is greater than TS, ito naman yung formula. So, under the conditions, ito na yung result. Naka-color coding siya. Next is the result SA will be multiplied to 9.81 meter per second squared. Then it is the spectral acceleration with the unit of meter per second squared. Step 8. Determine the corresponding spectral displacement. So this is the formula. Since SA at frequency is given, madali na lang natin yung pag-determine ng spectral displacement in unit using Excel. Step 9. Compute the modal responses. So, for modal lateral force, ito yung formula niya. So, for example, in F1, meron tayong 1.28. We will multiply it sa mass matrix and then times sa eigenvector for mode 1 times spectral acceleration. Using Excel, ito yung magiging result niya for mode 1. So to find the mode 2 to mode 10, same process lang yung gagamitin natin. Yes, ito yung magiging result niya for F2 to F3. So, ito naman is yung modal lateral forces figure. Ito yung itsura ng kanyang lateral forces in every mode. Ito yung kay mode 1, mode 2, mode 3, mode 4, and ito naman 7 to 10. Step 10. Compute the modal responses for modal story shear force. So, para makuha ang modal story shear force, ito yung formula. And since nakuha naman natin yung modal lateral force, so, para makuha yung V1, itong lahat ng V1, ang gagawin natin is copy natin yung last row, ang calculated F1 galing sa baba. Then, i-add the second bottom of F1 as the result para sa second to the last row of V1. Continue the process hanggang sa mode 10. Kahit maliit si modal lateral force, naging malaki naman si modal story shear force. So, ito yung magiging figure ng every mode. Sa baba, mag-una ng shear force dahil wala namang shear sa taas. So, ito pa. For step 11, ito yung compute the modal responses for modal story displacement. So, ito yung formula ni modal story displacement. Si modal mass participation factor multiply to eigenvector at multiply sa computed spectral displacement. Using Excel, ito yung result ng modal story displacement of every mode. So, yan. Ito siya. So, ito naman yung figure of mode 1 to mode 10. Step 12. Combine modal responses using square root sum of squares, or SRSS, for peak story shear V peak. So, ito yung formula for V peak. So, in the first floor, square each and add then square root. Then for V peak 1, the result is equals to 65.659 kilonewton. To determine and calculate the V2 and VPIC 2 and VPIC 10 to VPIC 10. So, same process lang yung gagamitin gaya ni VPIC 1. So, ito na yung result ng lahat ng VPIC from 1 to 10. So, ito rin yung kanyang figure. Dito pa rin tayo mag-start sa baba kasi share yung ating na-solve. For step 13, solve for peak story forces F peak. To solve for peak story forces, you need to subtract V peak I sa V peak I. For example, si V peak 1 minus V peak 2. And then, si V peak 2 minus V peak 3. V peak 3 is minus to V peak 4, so on and so forth. Para makuha natin yung peak story forces of every peak. So, ito na yung peak response, peak story force. Ito na yung itsura niya kung i-plot natin siya. So, step 14, combine modal responses using SRSS for peak story displacement delta peak. So, kunin naman natin ang peak story displacement using this formula. Lahat ng value ng first floor sa lahat ng node ay gagamitin para makuha si delta peak 1. Para makuha si delta peak 1. So, ito, delta peak 1 is equal to square root of 17.259 squared plus 3.700 squared plus 1.368 squared plus 0.729 squared and so on and so forth. So, the result is 17.735 mm for delta peak 1. So, para makuha naman natin si delta peak 2 to delta peak 10, same process lang yung ating gagawin. So, ito yung lahat na result for every peak. Ito yung kanyang peak story displacement. So, ito naman yung kanyang figure for peak response, peak story displacement. Step 15, solve for peak story drift. So, formula for maximum inelastic response is delta sub m is equals to 0.7 r times peak story displacement. Since given na yung r is equals to 8.5 at si peak story displacement na nasolve na natin kanina, i-substitute na lang natin siya. So, for delta m1, substitute natin yung r at delta peak 1. So, here, ito, makikita naman natin siya. So, same process lang din para makuha natin si delta M10. So, ito, substitute lang natin yung kanilang corresponding value for every peak. So ito yung result niya. Ito yung ating maximum inelastic response displacement. So, ito naman, according to NSCP 2015, 208.6.5.1, sabi is, calculated drift using delta M shall not exceed 0.025 times the story height for structure having fundamental periods of less than 0.7 seconds. Then, for structures having fundamental period of 0.7 seconds or greater, the calculated drift shall not exceed 0.020 times the story height. So, this is the fundamental period. For T1 is equals to 1.111 seconds is greater than 0.7 seconds. So, ang gagamitin para makuha yung maximum drift is 0.0220 times 300 mm since 3 meters naman siya kanina. So, is equals to 60 mm. 60 mm, ito yung ating maximum drift. So, dapat yung sagot is hindi lumampas sa calculated drift na 60 mm. To determine the drift of every peak, ito yung kanyang formula. For example, for drift peak 1, 105.526 mm minus 0 is equal to 105.526 mm. 0 kasi wala siyang floor sa baba. For drift peak 2, 322.235 mm minus 105.526 mm equals to 206.709 mm. So on and so forth. Yun, same process lang para makuha natin si maximum drift peak. So, since the value of drift peak 1 to 9 ay lumampas sa maximum drift peak na 60 mm, so gagawin natin siyang 60 mm. Since ang drift peak 10 is less than 60 mm, so ito yung gagamitin natin na peak story drift. Para makita, this is the response spectrum analysis of a 10-story building. And that's the end of my presentation, and thank you.